Hi everyone. Today I'm going to explain uh, the fourth module of 505, the foundations of cybersecurity sciences in this semester. The first module was the coding, second module networking, third module operating systems, and then finally database systems. That is the fourth module. So we have two lectures for the fourth modules. Um, the last module, which will be my last lecture, that is the next week. Then we will come back to Zoom meeting again. We will do hands-on practices, real practices. Okay. I want you to bring your MySQL running on your laptop so you can go together with me. Since the last lecture, which will be next the week, is our the last lecture and also the hands-on lab. There may be some of the hassles. So I am trying to give to you all the concepts and materials today. All right. Before we get into the this course materials, many of you are interested in and also expecting the final exam. Final exam will be on the 2 weeks from today. Okay. So next week, my last lecture, and the week after that, that is your final exam. All the policies for the final exam uh, will be the same as the midterm. So you guys already did the midterm. So I don't think you have any problems, but I want to remind you once more. Uh, once you start your uh, the exam, you have to finish it. There is no second chance. Okay. At each question, if there is a button, uh, I think it may be submit or complete, whatever the buttons that you can see, then I want you to click on it. And then at the last of, if you've done all the questions, then you can also click the button at the last. Um, don't try to uh, click the button finish up or whatever sounds like because I've never taken this the exam online, so I do not know what the button that appears at the last. Don't click that button that you are supposed to click on the last. If you click on that button, then it is done. You cannot come back to take the exam. What I'm talking about, there is maybe the small intermediate button for each questions. Uh, then if there is no certain button, you don't need to do, right? Another thing, the final exam will cover everything. It may be comprehensive. It's not really comprehensive. Something that you learned in this class. By comprehensive means, I mean, um, I'll ask about 20 or 25% from uh, the codings. Okay. Many of those coding questions from the midterm exams. If it's not exactly the same, then maybe small changes from them. And also 75 or 80% of the final exam will be from other three modules: networkings, operating systems, and database systems. Also, there is no sample test for your final exam because you guys already practiced enough for your midterm as well. One of the purpose of the sample test was I want you to uh, get accustomed to the online test. Questions types are similar to the midterm exams. Many of them are short answer questions. Again, if I ask you to fill in the blanks, then you need to fill in the blanks. Don't give me, I'm going to, grade as is. If you give me many lines of code, then it doesn't make sense at all. So you get 0 credits. For the questions that needs to fill in the blanks. Okay, I think that's enough for me to explain about the final exam. Also, you can bring some questions next week. Okay, today's the lecture, 2 things, the database concept and also the language. Okay, many of these languages will be practiced next week as well, but I want you to get a little bit of the sense of database languages. Okay, this database language is not like a Python languages. This is much more simpler. In general, database SQL language express what we want rather than how we want what. So procedure is not really involved in this declarative language. SQL is a declarative languages, or sometimes we call it non-procedural languages. On the other hand, the Python is a procedural language. Okay, so you have to do not only what you need to do, but also how you can get to that point. So somehow that is the reason it maybe a little difficult, right? Okay. So without further ado, we'll do. Oops. We didn't do this. How can I? I wanna this already. Oh, this already done. Presentation. All right. I am going to explain the terminologies. Terminology is very important. Database is nothing but a collection of data. Don't be misused of those. Database management system, also called DBMS, that is software packages, like our MySQL or Oracle, that is DBMS, software packages. It itself is not, does not have any databases. Database itself is just a collection of data. It's not on the computer. It's not on any software at all. On the other hand, the database systems, then it is databases that runs on the software. Okay. Let me see if I can get the pen. No, doesn't make sense. How can I get the pen? No. Okay. So example of database systems, the example of DBMS, database management systems, is Oracle, MySQL. Example of database systems like payroll systems, course registration systems, airline systems, banking systems, so on and so forth. Database models. Um, the primitive database model is file-based, flat database models. Um, the example for that, maybe Excel files. Excel file, if someone says Excel file is my database, then that's a file-based. It's not really at all database. Okay, it is just file. It can be deleted from your file systems. Your Windows, you can delete the files. If you have Excel files, then someone comes into your the Windows systems or Mac, and then grab that Excel files and go. So files can be compromised very easily. Other than that, all others, network, hierarchical, relational, object-oriented database, object relational database models, or others, they're all database models. So first bullet, not exactly the database models. It's just uh, some of the files. Network and hierarchical database models uh, had been available uh, many decades ago. Those are the first database models. And then later, recent days, hierarchical database models or network database models become a little bit of attention because the current database is not really structurally, conceptually rigid, uh, uh, constrained models. Uh, More like some of you may heard of that NoSQL database or Mongo database. Those are the somehow related with that, and also JSON data or XML data. Those data are about hierarchical database models, and all the web databases or the web pages uh, can be considered as nothing but a database. Then that is a network database models. Okay, so that came up very early, but because currently everything needs to be in databases, therefore web pages can be in the databases. Uh, so those models are also important right now, but not powerful DBMS available, not powerful database management systems, software packages available. Uh, Relational database models has uh, very strong and widely used and robust software packages like Oracle and MySQL. It has been developed about 40 years ago, and since then so it has been used very well. The weakness of the relational database model, by the way, that's the relational database model is the model that we are going to learn today. Weakness of that is uh, that doesn't represent efficiently the multi-value, doesn't represent efficiently composite values. Example of a multi-values is a phone number. Currently, uh, the phone numbers is not only one, right? Some people may have two or three different phone numbers. For example, myself, I have a cell number. I have my office numbers. I might have my home landline uh, as well, but I canceled a few years ago. So many numbers are available. So those are multi-valued attributes. It could be one atomic values, or could be a set of values. So each one has different. So it is not really efficiently handled in relational database models. Composite values, it could be uh, address, for example. Then address as a whole, it could be one value. For some other reasons, we may need street names uh, and cities, zip code, states, country, things like that. We want to hold each divided separate attribute names. We composite them all as an address, or some other reason we may need it, uh, some of the components of those component values. Another example for that attributes may be name. We can say name, John Yoon. Or for some other reasons, it may ask me to enter first name and last name and middle name, right? Those are not really efficiently uh, managed in relational database models, but it could be very efficiently represented in object-oriented database models. Some of the drawbacks of relational database models can be resolved in the object-oriented database models. Not all the features in relational data model are weak. Some some associated with the relational database model is really, really good. One example is SQL, structured query language. That is a very, very strong point in relational database models, which means then it could be a weakness in object-oriented database models. In object-oriented database models, uh, there is a language like SQL for relational database models. Many cases we call that OSQL. O means object-oriented. OSQL, that is also very, very powerful to express. Powerfulness in expression doesn't mean the easiness uh, uh, using, right? It's not easy to use. SQL for relational database models, that is very easy, easy to learn, easy to use. The language uh, efficiently expressed in object-oriented database model is not really efficient. It's not really easy, although it's powerful. So relational database models and object-oriented database model both have trade-offs. Weakness of one side will be strength of the other side, and vice versa. Therefore, about since 20 years ago, object relational database model has been discussed and also implemented in the current commercial databases like Oracle. Object relational database models. As you can imagine, object relational database model therefore can handle multi-valued attribute. It can handle also composite values to attributes. It can also use SQL. You can use simple SQL language, or you can use expressive, powerful language like OSQL in object relational database models. Concepts that we need to learn. We need to learn schema, relationships, relation schema, database schema. As an example, here in think of the university database. Then we have students, department, faculty, and course and enrollments. Okay, database. Uh, these three I already explained, right? Database management systems and database systems and database. Relation is nothing but a table. In relational database terminologies, relation means a table. It is not relationship. So relationship is different. Okay. If you see here student, then that is a table. This is an entity. Department, this is a table. This is an entity. Faculty, this is a table. That is an entity. Course, that is a table. That is an entity. However, enrollment is a little different, right? We can say student enrolled in a course. Students enrolled in a course. Then student and course, subject and objects, enrolls like a verb. That is a relationship between the two entities, between subject and objects. The relationship is kind of the verb in the languages. So enroll. In this case, enroll becomes a table. Sometimes the verb not necessarily become a separate table. It depends on uh, the semantics in that uh, application domains. And also you can see here, I need is this real? How can I get slide to show? This is a Shift F5. That is slide to show. So if I do Shift F5, it doesn't. Shift. Oh, this is what about uh, my pen? Control P. No. How can I get my pen? Hmm. It's bad. It's print, right? I really need a pencil. Hmm, Alt P. Hmm, hmm, Function. It's okay. Anyway, so on the line here, that students can be uh, described as CWID, name, age, and major. Okay, and student is a table name. So this expression is called relation schema. Relation schema is a set of attributes. So CWID, name, age, and major. We could add the type. So we have integer, text, so something like that. Text is very, very handy type, but you can use character and then variable character with some uh, fixed length or variable length. You could do that, but in this case, we simply do text. Because we have multiple tables, so each table has the schema like this: name and type, attribute and type pairs. Attribute type pairs in parentheses. And then there is a primary key. The attribute primary key is an attribute or composite attribute. It could be multiple attribute together will be a key, but at least actually primary key is a minimal set. So CWID is the key for students. Department name is the key primary key for the department. Uh, and faculty name is the primary key for faculty table, and so on and so forth. And here, the department name is the same as here major. This is not right. We can go here. Major is the same as student major in student table. It's nothing but department name in the department table. Department name in the department is a primary key. They use the same value. There's no student who has majors that is not available in the department table. Student major should come from the department table, right? So this is a primary key, and the same values in another table. It is called the foreign key. That's what I'm saying here: primary key and foreign key. Same thing. Faculty's department, that is a foreign key because it itself is a primary key in another department, its own table, which is a department where that department name is the key. And currently that is available in the faculty, but that is not the key for faculty table. Key for faculty table is faculty name or faculty's social security numbers, right? So department is the foreign key and name is the primary key. It goes like that. Consider two tables, faculty and students. So faculty has a faculty name and department. Student has CWID, name, age, and major. Two tables currently, as you can see, um, are not related. There's no connection between the two tables. Separate two tables. You can say simply separate two Excel files, spreadsheets. They are not in the database. There's no relationship. If we have all the tables in a database, should be related directly or indirectly. Faculty and students may be related in this way. Faculty teaches students. We could have three tables, right? Faculty table, teaches table, and student table. They are related. How they are related? Teaches table, one attribute comes from faculty, another attribute comes from students. Of course, in the case, those two attributes in the teaches are foreign keys, right? Because James, that is a value for faculty name, which is a primary key in the faculty table. And then student CWID 1113, that is I'd rather use my mouse, although I cannot do anything. But this 1113, that is the value here in the student table. CWID value. CWID is the primary key for the students, right? Usually, if it is a primary key in this representation, then we have underline. Underlined attribute is the key. Okay. If there is no underlined, then it is not the key. It is not primary key. Foreign key, we don't say anything. But we need to specify, hey, major here is it's a foreign key for the name primary key in the department. We should say that. Otherwise it should be the same name. If we have department name, D name, then we should have a D name. Well, at least even if this SQL language, we have to specify it. Otherwise, system does not know. Okay, in this way, they are related. So that is relational database models. So all the tables are somehow related directly or indirectly. These two tables are directly related, right? Based on faculty names. Teachers and students tables are directly related based on CWID here. Therefore, faculty and students are also related indirectly. In relational databases, tables are related by sharing attributes. We share name here, faculty name here, and faculty name here. Two tables share the same attributes. Teachers and students, two tables share the same attribute, CWID. Therefore, they are related. This is relational database models. We can extend it to object relational database models. The very same schema, student, department, faculty, enroll, and courses can be represented here in object relational database models. I'll give you 15 seconds so that you can see the difference between these two. Difference here, the students, the type major. In relational database, the type for the major in the student table is just simply text. However, in object relational database models, type for major is a department. Department is yet another table name. Table that become a type. This is exactly the same concept as object-oriented programming. Once you define a class, then it can be used as a type. Okay. Similarly here, faculty, DPT type is nothing but department. Enroll, faculty here, in relational database, enroll has two attributes, fac and student, two attributes. Fac is text. In relational database, this fac is nothing but name in the faculty. So the type for faculty name is text. Therefore, fac in enroll table is text. Similarly, student in enroll table is integer. That is, this is a foreign key and primary key here in CWID. Type for CWID is integer, same type. Stay shared. Okay, by sharing attributes, students, and enroll are really connected. And then by sharing fac and name, they are the same attribute. Therefore, faculty and enroll, two tables are related or connected. On the other hand, here in object relational databases, enroll fac, type for the fac is faculty table, table itself. Students attribute in enroll table is nothing but students. The representation in relational and in object relational databases makes much more sense. That is because enrollment is not just two attributes are enrolled. Actually, faculty and students are enrolled together, right? It's not faculty name teaches student names. It should be faculty teaches students. So this makes really sense. Faculty enrolled in the students. Faculty teaches students. The type is not just simply literal faculty name, but faculty as a whole. So faculty as a whole teaches student as a whole. So object relational database model represents the real world as it is, right? It's not when we describe students, we don't describe only student CWID. We say students. That is an object. Okay. We'll look at this student enroll and course and university database uh, in another module here. Okay. So I need to minimize this. This is another module. So shift F5, and I am trying to. Okay, very nice. So we need the MySQL installations. MySQL can be installed on Windows platform or on Mac OS platforms. My another lecture for both Windows and Mac OS already recorded at my side and posted. So you may access at least one. You could access both of those for your better and more understanding. Both are available. Therefore, I cannot meet you because some students runs on Windows, some students runs on Mac. I cannot give you a lecture only based on one. But next week, once you have one or the other, and our work is command line. So you can bring up terminals. So I can explain everything on terminals. So it should be the same terminal as, there's no difference between Mac or Windows. Only slightly different, but I can explain that to you. Another thing is MySQL. I already explained that. We are going to work on terminals, okay? Terminal, rather than GUI. If it's GUI, then Windows GUI is not the same as Mac GUIs, so we work on terminal, command line database access. What we're going to do, whole pictures of a database is we need to create database and create tables. Create one database. Within that database, we need to create multiple tables. Of course, tables are connected one to another. And then we need to populate data. Okay. And finally, we'll retrieve the data, querying a databases. We can access one table. We can access multiple tables to be joined together. You can download from here and install it. And then for Windows users, you can run. You don't type run, simply C:\/ program files / MySQL space server space 8.0 / bin for binary /MySQL space -u space root if you want to access your MySQL through the root privileges space -p followed by password, but you do not need to type your password here. Hit enter, then if this is accurate, then it'll return your MySQL prompt. And then it says enter password. Then you can enter the password. For Mac users, you need to download it, open system settings and locate MySQL on the navigate panes. In that way, you can see, hey, where is MySQL? Your MySQL that is available in system settings. But you don't do anything on that. Just make sure that your MySQL is that appears here on your system settings. When you start your MySQL, you need to have terminals. You can locate your working directory all the way to that location /usr /local /mysql and /bin. Once you are in that location, you can simply type MySQL space -u space root space -p, hit enter and enter your password. Or you can type from anywhere /usr /local /mysql bin this. Then you will have the terminals. Once you have the terminals, then you have to think of this as There are two designs. We start with the conceptual design. Conceptual design, one of the best tools for conceptual design is ER diagram, entity relationship diagrams. I know some of you already know ER diagram if you have the IT experience in your work, or someone who come from maybe uh, information systems. Of course, you should know if you have a computer science background or even business school. They teaches ER models as well. So this is very common. What it does is that the the upper one explains uh, the requirements. If a requirement says students enrolled in a course, then student is a subject and course, that is object, enrolled in, that is a verb. So that statement can be depicted in these ER diagrams. Square is an entity, diamond is the relationships. So student and course, those two entities are related. So this is a relationship. Similarly, faculty teaches course. Only here, in this diamond, this is only solid line. Here, there is an arrow. Arrow comes here is not accidentally, but purposely. What it does here is that if there is no arrow, that it means many-to-many relations. If there is an arrow, that it means one-to-many relations. How you can interpret it in this way. If this is a many-to-many, then A students can be enrolled in many courses. You can interpret that in this one direction. You can also interpret it in reverse direction. A course, each course can be enrolled in by multiple students. One student can register multiple courses. One course can have multiple students. That is a reality, right? You have to listen and think very carefully. On the other hand, this is one-to-many. One faculty teaches many courses, but each course should be taught by one faculty, not many faculties. Each course should be taught by one faculty. Here's one faculty. There's difference, right? Here, one student can be enrolled in many courses. One course can have many students. One faculty can teach many students, many courses. One course needs to be taught by one and only one faculty. So because of that difference, when we convert this diagram to a table, if this is many to many, then of course this square, each square will be a table. Students, that is a table. So there are multiple attributes. Course, also tables. But enroll, if it is many to many, then enroll itself is another table. And this enroll, this relationship, this diamond can be converted into a table with the attributes, one from the primary key of each tables. This guy enroll will receive, will borrow, will share the primary key from both sides. Primary key for students is the CWID. So CWID comes here. primary key for the course, that is a CRN number. So CRN number appears here. This is very well defined tables. So from this one very simple ER diagram, we have three tables generated. This course, this is the same course, right? Can be taught by faculty. We have one-to-many relationships. Of course, box will be a table. So faculty, there's a faculty table. Course, there is a course table. Okay. If this is one-to-many, then teach is not converted through a separate table. Not like here, enroll will be a separate table. Here, no. Instead of its own separate table, but we have to link, right? So faculty from one side, faculty primary key can be shared with the course. So faculty instructor name can be shared with the instructor here. Okay. So start with the conceptual design. Start with the conceptual design, and then we do logical design so that we have a table relation schema, right? Relation schema. If we have relation schemas, all complete set of relation schemas, that we call that database schema. Database schema. Once we have a database schema, then we can define that into our real operational database, MySQL, using DDL. DDL language stands for Data Definition Language. In relational database, there are two languages available, DDL or DML. DDL, there's a definition language. DML, manipulation language. So data manipulation language. That comes a little later. So first, the DDL. So using DDL, we can create database, create table, and so on and so forth. Create users, define access control, insert data into tables. Not only access control, but also authorizations. More specifically, who can do what. Not only you can come in. Create database. This is the language. Create database name. If it is created, if there is no error, then you can connect, you can get into that database by saying use the database names. Once you get in the database, specific database, then you can create a table. This is the language. Create table, the reserved word, followed by your table name, students. Open parenthesis and CWID type text, comma, name, text, comma, date of birth, text, comma, major, text, close parenthesis, and don't forget to end with a semicolon. Database languages, there is a delimiter for ending, semicolon. If you don't put semicolon but hit enter, then it'll wait until you hit enter. Why the semicolons? Because database language is sometimes very, very long. It's not only, it doesn't end in one line. It could be multiple lines. So it lets you enter. If you complete the description of your one statement of SQL, then you can type semicolon. Then your DBMS understands, hey, this is the end of SQL expressions. And then you can create a user if you want. Create user, reserved word, followed by your name within quote, at sign, and then within quote, maybe IP address if you are connecting to remote databases. Currently, we are working on the local database, so local host. Identified by, there's a space, reserved word, and then you can put your password ending with a semicolon. Once you create user, initially user does not have any privileges, so that you can, if you want to give privileges, then this is the language. Grant privileges. If you grant all the privileges, then you can say all. If you want to give only delete privileges, say delete. Or create privileges, create. Some of the languages here instead of all. And on star.star. First star, that is the wildcard for any database. Dot, second star means table. Any tables in any databases. If you allow this guy, John Yun, to do anything on any table of any databases, then you need to do this way, star.star. If you want to specify a specific database only, then you need to say here database collegedb dot star. Or if you want to give only privileges to specific table, then collegedb dot student. Then this guy can do only on that student table. You can limit also privileges. Okay, select. You can select on that student table. You cannot create, you cannot delete, you cannot modify, you cannot do anything, but you can read it, select, you can retrieve it, then select here instead of all. So once you create table here, tables, then you can insert data. For each table, you can insert. For student table, insert into students, and then list of attributes, values, and list of the values correspondingly. CWID, Chris, that is student name, and this is birth date, DOB, the major, cyber, close parenthesis, and semicolon. If the list of this attribute is exactly the same list that student was defined as a table, then you don't need to do this. Okay, sometimes you need to enter only CWID, yet these three is not available. Then you need to say CWID and then one value is only here. But if you want to enter all the values in the same way they are defined originally, then you don't need to do this. You can simply say student values, open parenthesis, list of values, close parenthesis, and semicolon. Authorizations. We can specify who does what actions on what data items. And that should be enforced automatically when that person comes. So a lot of overhead required. Not only that, that is only available on the commercial and expensive databases. Oracle database, yes, it is. But MySQL, this is free. No. Then impossible to do that? Yes and no, right? It is yes if you do some of the codings. You can do the same effect. So some of the coding needed, but we don't do that in here. Okay, and DDL that we looked at already, right? So in addition to this DDL, when you complete this DDL, then a database is ready. Then we can use it using DML. Now DML, data manipulation languages. DMLs usually select from where, group by, order by, where in, select from where in, another select from where. This is a nested, okay? Nested SQL. More complicated SQL. Examples follows. Simple example is if you have a database table, a relation called the employee, if you want to get all the values, all the rows and all the columns, then you need to say select star from employees. If you want to specify, if you want to limit columns, then you need to list those columns. If you want to limit the rows, then you need to have a where clause. Like here, where clause, country, USA. Group by, if you want to say some of the data analytics. So I want to count. I want to have tables. So which job title, for which job title, how many employees that we have. Then, for example, programmer, we have 19 programmers, a salesperson, 5 salesperson, that type of things. Some of the summary tables needed that can be generated like this. How many? The count not recorded on your database tables, but you can count it as you do SQL statements. So select count star, comma, job title from employees, group by job title. You can group the tables by job titles. Order by if you want to sort. Wherein, this is another the nested stuff. Group by having. When you do group by, but some of the conditions, then you need to say having some of those, right? And then select from where in another select from where. In relational database, wildcard character is also available, but not star, but percent sign. Why not star? Star is already we used here. Count star or select star from. So we cannot mix use that. This star, this wildcard can be used here. We want to select limited attribute from employee table where first name like first name start with A. We don't say A star, but A percent. This is wildcard. If you want to ask, I want to have the first name start with the T, but don't care in the middle of middle character, but end with M. Tom, Tom, whatever, right? So in that case, we need to have underscore. Underscore for single character, percent sign for wildcard. You can union two tables. So select this first one, select from customer. This is one table. And bottom here, that is another table. Select from employees, another table. But you join the, you union them. Those two tables can be unioned. And then you sort them, order by first name and secondly, ID. If you want to join two tables, then on the from, there's a list of tables, employee and office, inner join. You want to select only three attributes from joining the two tables and with the conditions where office code is the same as office code for employee is the same as office code for office. E from employee, E, that is the acronym. Well, this is only uh, yeah. So E for employee and O for office. So O code means this is an attribute available on office table. This attribute available on employee table. They should be the same, equal. And also, and country equals USA. Okay, this is it. The lecture about the concept and the language. And next week we will look at the real practice. And also next week will be the last lecture from me in this semester. And week after that will be your final exam. All right. See you next time.